2.2, number 104, time for an athlete. An athlete swims from point A to point B at a rate of 2 miles per hour. Okay, so swim 2 miles per hour. And runs from point B to point C. It runs at 8 miles per hour. Use the dimensions in the figure to write the time t required to reach point C as a function of x. Alright, so t is a function of x. We're looking for t of x. So we'll solve for t and it'll have x on the right side. T is a function of x. Okay, so they included a drawing. This is a sketch. This is 3 miles. This is 1 mile. Many of these story problems you will see again. This is another one where in calculus you'll have the same scenario. You'll have to write it as a function, and then after that you'll be asked to find the minimum or maximum of something. So this person is swimming to B and then running to C. So that is the path that this athlete swims. In calculus, you'll probably want to minimize the time. So if we're trying to figure out how to get from here to here, knowing that this person can swim at 2 and run at 8, you would probably want to minimize the time. Minimize the distance, you would just go straight to C, but you wouldn't want to minimize the distance there, you want to minimize the time. Okay, so we know that distance equals rate times time. So time equals distance over rate. This already is a distance. That's a distance. We want to figure out, well, the time in the water on land is equal to the time total. So if we add those two together, we have a time function. Okay, and this is the path. So we want to figure out the time in the water, the distance on the water, and divided by the distance or the rate in the water, plus the distance on land divided by the distance in the water. That's equal to still the time total. Alright, so that's kind of the groundwork of here. Let's find the time in the water. Well, what's the distance in the water? This right there is the distance in the water. We don't know what it is, but we do know this is a right triangle. X squared plus 1 squared equals this squared. So this is going to be the square root of x squared plus 1 squared. So x squared plus 1. That's our distance in the water. So that will be square root of x squared plus 1 divided by our rate in the water. Well, that's given to us. That's 2. Plus the distance on the land. We don't know that. We do know this is 3, and the book defined that to be x, so this would be 3 minus x. So that's our distance on land, 3 minus x, divided by, this should be rate. I'll change that. There. The rate, oh geez, rate on land. Hopefully you viewers saw that all along. I don't know what I said, but this is not what I was supposed to write. Okay, so distance on land divided by the rate on land. So the rate on land is 8. X. That would be our time written as a function of x, where this distance right here is your x.